In this video, we're going to talk about frequency distributions and their graphs for quantitative data. Now, this is a lot like what we just did with qualitative data, except now no natural categories exist. So we actually have to take our data and divide it into non-overlapping categories that we call classes. And sometimes this is actually done for you. And so you just have to interpret the frequency distribution or work with it somehow. So let's take a look at this example. We've got 20 batting averages of the starting players from the Detroit Tigers and the Boston Red Sox. Now, just a quick note about batting average. When you see an average of .275, that means that an individual batter is getting a hit 27.5% of the time that they're up to the plate. Or this individual hitter with a batting average of .302 is getting a hit 30.2% of the time that they're up to the plate. But in baseball, we usually don't talk about batting averages as being .275 or .302 or .272 or .296. We simply say 275, 302, 272, 296. So with that in mind, I'm actually going to drop the decimal points throughout the remainder of this problem, and let's just think about these batting averages as whole numbers, but try to remember what they really represent. Okay, so I'm looking at the data. I see that the lowest data point is 201. The highest batting average is 319. And so given that, and that I don't want to have a very large number of categories or classes, and that I also want to have categories or classes that have an equal width, I think that creating categories with a width of 20 and starting with 200 for the first category makes a lot of sense. So I'm going to create my classes as follows. I'm going to say that we have a category or a bin of 200 to 219, 220 to 239, 240 to 259, 260 to 279, 280 to 299, and then 300 to 319. And so just a quick note about these classes or these categories that I just made. These are lower class limits. The lower end of each category or of each bin is called the lower class limit. This is the set of upper class limits that you see here. So the upper end of each category or each class is called the upper class limit. Now the class width is something that people often get wrong when working with these distributions for quantitative data. They'll look at this and say, oh, it's 200 to 219. I think that the class width is 19. And they would be wrong. We define class width, as you see on the bottom here, as the difference between consecutive lower class limits. So the class width here is actually the difference between 200 and 220, or 220 and 240, 240 and 260. So the class width in our example is equal to 20. Okay, now that we have our categories set up, let's figure out the frequencies for each category. So I'm just going to make tally marks, and then we'll figure out what our totals are. So we have a 275, that's going to be in here. We have a 302, a 272, a 296, 202, 319, 237, 254, 297, 294. 298, 310, 201, 248, 250, 299. And then the last column, 302, 222, 319, and 228. And so our frequency distribution would have the following numbers. We would have 2, 3, 3, 2, 5, 5. Now don't worry, this is not how you're going to be doing this. We're going to talk in a little bit about how to use the calculator to do this, and it's really convenient to get those counts quickly in the calculator. But I'm just showing you how you would come up with it, and this is now our frequency distribution for our quantitative data, and we could likewise look at a relative frequency distribution. And so if we just took all of our frequencies and divided by the total of 20, we get relative frequencies. So 2 divided by 20 is 0.1, 3 divided by 20, 0.15. We have another 0.15. We have another 0.1, and we have 2.25s. And remember, those relative frequencies should all add up to 1. So we have 0.5, and then 0.75, and another 0.25, so that does add up to 1. Okay, so now let's take this and talk about how we can plot it in a graph. And so we're going to make a bar graph, except this time our bar graph is actually going to have bars that touch. And as a result, we give this a new name. Instead of saying we have a frequency bar graph for our quantitative data, we say that we have a frequency histogram for the quantitative data. Now, like I said earlier, you're going to be doing a lot of this in the calculator, but if you are doing it by hand, or even if you're not doing it by hand, you should note that the values that you're going to have on this horizontal axis are going to be the lower class limits. And so I'm going to label this as 200, 220, 240, 260. Those are all of my lower class limits, 280, 300, and then 320. And we saw that our frequencies went as follows. We had a frequency of 2 for that first category. And then from 220 to 240, we had a frequency of 3. So see how I'm creating these bars touching now? From 240 to 260, we also had that frequency of 3. From 260 to 280, we went back to a frequency of 2. And then from 280 to 300, we had frequency of 5. Likewise, from 300 to 320, we had a frequency of 5. And so I'm just going to label that in here real quick, 2, 3, 3, 2, 5, 5. And so again, this kind of speaks to the fact that a picture conveys what's happening with our data oftentimes much better than what we have in a table. Okay, so let's see if we can create this histogram now in our calculator. Let's see if we can actually just take the data that we had, put it into the calculator, and produce this type of a frequency distribution known as a histogram. And so here are the steps. The very first thing that we're going to do is we're going to press Stat Edit to enter the data into your very first list. And I've already done this, so if I press Stat Edit, you're going to see all of the baseball batting averages in the calculator. Now what I'm going to do is I'm going to go into second y equals, and I'm going to turn the plot on. So again, this is second and then y equals, and I have to press enter to turn the plot on. And I want to select the picture that is a histogram, or the one that looks like a bar graph, and that's the middle one here. Some of your calculators will have 2 rows here, but it's the same order of pictures, and so the third picture is the one in all of our calculators is the one with the histogram. Okay, so now after we do that and we select that histogram picture, we press Zoom Stat, and that is zoom number 9. So if I go to zoom, the top here, and I see down here Zoom Stat is number 9, I can just press the number 9, and it's going to give me a histogram. And as you're looking at this right now, you're thinking, well, that doesn't look like the histogram that we created. And the reason is the calculator, when they made this histogram, thought that there would be a better class width than the one that we chose. Remember, when we made ours, we said that the class width should be somewhere around 20. But when the calculator made this, looks like they did something a little bit different. You'll notice here that I said you can view the graph, and then you can press the trace button and arrow over to view the important characteristics of each class. And so if I press trace at the top, you can see that they started the first class at 201, and then they went up to 224.6, somewhere in there. And it looks like 224.6 would be the lower class limit for the next class, and you have an N of 3 in that class. And you can arrow over, you could see the counts in each class, and you know, as you do that, it gives you the information on how the calculator set all of this up. But you're probably thinking, well, no, I want it to look like the one that we created. And so what we can do is we can make that happen. We can press the window button, and we can modify the class width by changing X scale inside window. So if I press Window at the top next to the Y equals menu, I'm going to modify, where is it? Here it is, X scale. So they actually have a class width of 23.6, and in our example, I created a class width of 20. So let's be consistent with my example. But I also have to change my X min. Do you remember what I started the very first class with? I started the very first class with 200. So I need to put that in there. And then I'm going to make X scale 20. So now that I have that, you would just go back to graph. So after you make this modification, you're going to go back to graph, and you should be able to see exactly what we have in our histogram. And there it is. And if you press the trace button, you can see that the min is 200, the max is less than 220. So it's acknowledging that 220 is really not part of that first class. 220 is really the lower class limit for the next class, but we have an n of 2. If you arrow over, see now it says the min is 220, the max is less than 240. So we're able to see everything that we need based upon just plugging our data into the calculator like this. And the nice thing is it also gives us our frequencies that we could fill in a frequency distribution. 2, 3, 3, 2, and then as you arrow over, you would see that this is 5 and this is 5. Okay, one other little thing with these distributions, with these histograms of quantitative data. We are often interested in how do we describe the shape of these histograms. There's a number of terms that we use, and so check out the next video to see what those terms are and what the histograms look like when we use those terms. Thanks.